Just saying, garlic fingers are vegetarian, so that's an option. That's a nice thing. We're not going to talk. Oh, wait, hey, we are going to talk about the Earth today.
Yeah.
Totally.
Yeah.
And how healthy asteroids are for the development of. Never mind.
Yeah. Sorry, I just saw the YouTube video. We're gonna hit the start button. Usually I try to get the start lined up, but I just saw the YouTube video, and the start of the YouTube video is garlic fingers are vegetarian. So that's good. All right, we're gonna get started, everybody.
Time is X minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Woohoo! Here we are again for the Moon at Noon. Today, I'm pretty sure I have chocolate in my teeth because I've been eating our project. We're gonna start today with tonight's targets. So our day that we're profiling today is Q day 2, which means that the moon is more than half full in the sky. And it means that we're going to be observing tonight because tonight is Q day 2. So hopefully it's clear for you. It's clearing here at 8 p.m. in theory.
It snowed all day yesterday in Waterloo. So I was like, oh, I'm not going to go out. And then 11 p.m. at night, it was just perfect. So I had to go out. Drop in the comments or if anybody was able to do any observing while we go over these targets.
Yeah,
It's rainy here in Halifax. We should introduce each other for whoever's new to the stream. This could be someone's first day.
That's true.
Yeah.
So I'm Jenna. I'm the outreach coordinator at RASC and stuff. That was vague. Samantha.
I'm Samantha. I'm outreach assistant. So I'm basically Jenna's right hand man, female, woman.
And I'm John. I'm not sure why they have me on this show. I'm the telescope operator at the Burke-Cafferty Observatory in Halifax, Nova Scotia, and author of 50 Things to See on the Moon.
And better at introducing himself than either Samantha or I.
He's got more practice. It's not our fault.
So John's written a book on the moon, and John is also the only one of us three who has his Explore the Moon certificate. So
I'm working on it. Okay.
Yeah.
We're both working on it during this.
Yeah.
Happy Earth Day to everyone too.
Yeah, and happy Earth Day today as well. We were gonna talk about craters last time, but then we got distracted by sketching. So today we're gonna talk about craters as we also go over our targets for tonight. So we're gonna start with targets. We're gonna jump into a couple other little bits and pieces, and then we're going to make some craters, which you're welcome to do with us if you would like. Oh, hey, look, it's us. All right, so here is our Q day 2 target list. It's a nice big moon today, and the kind of cool thing about the targets at this phase is that they're visible for quite a while after the terminator goes past them. So while these seem like they're a long way away from the terminator, you can actually see them pretty well. There are these targets over here. So we got lots of space, lots of things to see. Before we jump into those, I just wanted to shout out to Lisa, who posted this on Facebook, and I thought it was fantastic as an excellent demonstration of why the terminator matters, because this was Q day, I guess that would be Q day 0 or Q day -1, and this would be Q day 0 or Q day +1. You can see a whole bunch of craters here, and then suddenly they're gone. So that terminator really helps. These are still here, obviously, they're here, it's just they're way harder to see than if the terminator's right on them. So that's why the terminator matters.
Yeah, great photos too. I mean, I think that's just with a spotting scope and a phone that she used. So yeah, awesome.
Lisa also already holds the Explore the Moon certificate too. I think she did it before we even got started on this program. So kudos. And was the first person to achieve the Explore the Moon the Explore the Universe certificate after we did that program last summer. So yay for Lisa. Well done. And thank you for posting all of the things that you do online so that we can see too. So today's targets, was that the only thing we wanted to cover before we jump into today's targets?
I think we were just doing a brief one of the main things I ran into when I was doing it is, what do you put in the description?
Right.
Like I put the name, and I put, one of them looked like glasses because there was two craters connected to each other. Another one looked like Mickey Mouse. But is there anything more technical I should be putting in there?
So I thought that the description part was mostly to help you. So it's like some notes to yourself that will help you in future observations, because the description is not necessarily a requirement for the program. You just need to prove that you've seen the objects. But you can also use it to describe them. So for me, I used the number system in my drawings and then used the description in many cases to then write out the words and describe what I was seeing. So it's really up to you how you use it. But I found the most helpful way was to write down things that will help me with the next day's observation. Like, oh, missed this crater this day because it was too, it was just beyond the terminator. So make sure you don't miss it for the next observation. So
on that note as well, so there are apps, and I think I've talked about Astrospheric before, which is the one that I use, that tell you exactly what percentage full the moon is. And so if you're going based on the Q-day system, which we've had some comments about, so we'll address that in a second. If you're going on the Q-day system, it doesn't give you specifics down to like percent full that the moon is. So if you go out on, let's say, Q-day 2, and the moon says that it is 70% full and you can't see something, then check on the next lunar or Q-day 2 and see if it's 75% or 77% full, and see if you can maybe spot it when it's a little bit fuller. So that's another option. I would like, personally, I like writing down the percent full that the moon is on the night that I'm observing.
So what would be, so I guess the pictures and descriptions aren't like fully required, but what's the main point about filling out what we have to have filled out to prove that we've observed it?
Date, time, what you're using to observe, and then what you observed, right, John?
and usually sky conditions are helpful
Sky
as well.
conditions. So that's all you need. You don't, and a description of what you observe, which can be a drawing or can be writing or can be a voice note if you want, I think. And at least if you take voice notes, you can then transcribe it later too.
Yeah.
So first of all, yay for Jamie, who bought a new telescope. Hooray. And it hasn't affected us too much other than it's snowing in Ontario. So we'll blame you for that.
I got clear sky last night. So,
yeah, that's true. So it's fine. It's fine. Yeah. And then from Colleen and a couple other people, why Q days? Now we did not develop the program, and Dave is in the comments and mentioned that it was just a new way to look at things. The kind of nice thing about Q days is that if you're looking at it instead by lunar days, and you can see some targets early in the lunar cycle and later in the lunar cycle. So you're looking at like lunar day 4 and lunar day math, 21 plus 4, lunar day 25. With Q days, that time that you can see those targets is the same in the first half of the cycle as it is in the second half of the cycle. It's lunar day 2, or sorry, Q day 2, no matter what. So that's kind of helpful for some people. It's a new way to look at it.
It depends. If you're using like 50 things to see on the moon book, I just go 1 to 14 and I basically leave out the waning phases altogether.
Mm-hmm.
So
yeah, that's the other thing too, is that it leaves room for people who are morning people if you want morning people. I'm not, so that's a pass for me. But for someone like who am I to say that you don't want to observe first thing in the morning? So the Q days kind of help in that way too, where it gives you, where other things like John's book, super useful. Probably the majority of people are observing in the night. We should do a survey on this. Maybe we'll do that next time. See who's observing at night and who's observing during the day or in the morning. For those who are observing in the morning, it might not be as intuitive to use that 1 to 14 day cycle. But who knows? Yeah, just a new trying new things. So without further ado, here is our moon for tonight.
Right?
Yeah, tonight.
Cool.
I'm going to zoom in on our targets so that we can see them. We do have some Apollo missions tonight, which is nice. And then this is just in general a very nice time because there's these really lovely craters right in the middle. Samantha, do you want to go through them at all? Or do you want me to?
You can go through them. I have not actually looked at this Q day yet through my telescope. So
John, do you have any? So we have a couple mountain ranges. So up at the top of Mare Imbrium and at the bottom of Mare Imbrium, we've got some mountain ranges. Copernicus is probably going to be the centerpiece of what you're looking for. So if I were you, if I were me going out tonight, I would find Copernicus and do everything based on where Copernicus is, because it's so bright and big. And so that's, for context, this really, really big crater with this big ray system, which we'll talk about later, right in the more or less middle of the moon.
Mm-hmm. As a first-time viewer, I was having a lot of problems figuring out like what map matched with my telescope, and the best way to do it was to find something like Copernicus and just hop from there, almost like star hopping, but like crater hopping on the moon.
On the moon. Yeah. So Copernicus, Reinhold, and Landsberg will for sure be the easiest ones to find, with the Apollo missions ending up pretty much right below Reinhold and Landsberg. Yeah. Bearing in mind that, first of all, those are optional, and second of all, you don't actually see like a thing. Like, you're not looking for the lander. It is too small.
Bonus points if you see the golf ball from Apollo 13 or Apollo 14, but
we should get a new certification level for people who can see that.
I don't have anything that would be able to get that close. What did you write? I assume, John, you found the Apollo missions because they're one of your favorites. What did you kind of see through it, or what was your
I mean, because it's impossible to see them, from even Hubble can't see them from Earth, right? You just basically observe the sea in which they're in pretty much and be like, yeah, that's where they are. And then you just appreciate the accomplishment that, human beings made. And then you can go read about the missions because they're very interesting. Like Apollo 12 was the first pinpoint landing. Apollo 14.
What does that mean? Apollo 12 first pinpoint
landing? It needed to land exactly in the spot. Like, they were not like, we're just going to land in the Sea of Tranquility. Apollo 12 was like, we are going to land at the exact site of it was a Surveyor 4 mission. So there's another spacecraft, a robotic spacecraft, and it landed in the same spot within, 300 meters.
Wow.
And so the idea was that they would go, and they did, and they went to the other spacecraft, and they did all sorts of analysis on it to see like, okay, what's it like? What happens to a spaceship that's been on the moon for a year or 2 years? So that's what Apollo 12 was, all about, or that's what they're most known for, is this pinpoint landing. Yeah.
So then I guess if you're looking at this is from, just a reminder, this program here, the Dial-a-Moon thing on NASA's website. You could, if you have a high power enough telescope, i.e. if you're not using binoculars, you could go in here and look for other craters that help you find where this might be. So like this forms a nice little, I can't remember what kind of triangle this is. Sorry, high school math teacher. Isosceles?
Isosceles, yeah.
Isosceles, yeah.
I just taught students about this and I still can't remember.
So you can find little tricks like that to help you find where these might be. But yeah, it's just cool to be able to look at this and go, that's really neat. Like they landed in among all these craters, and just so cool.
What one are binocular targets? Because I took the binoculars out for the first time to really look at the moon, and I didn't realize the stark difference between looking through my 140 millimeter refractor versus a binocular.
I forgot to pull up my magic spreadsheet this time, so we'll just jump in right into the list for binocular targets. There are only two, so it's just Copernicus and Mare Imbrium. So easy night for binocular targets, harder for everybody else if you look at the number of targets that are on here. So you're, as a binocular person, you're just looking for these and this Mare and this crater here. Yeah. So depending on what you have, you might either have a very chill or a very busy observing night tonight. We have three mountain ranges. We have the Straight Range up here. We have the Carpathian Mountains here, and then we have the Ripheus Mountains.
Yeah. So I like to nickname them all. So the Straight Range for me, that's the hot dog. If you go back to or not Straight Range.
I want to see up here.
Yeah.
This top of Mare Imbrium. Is that this?
Yeah. So I call it the hot dog. And then if you go down to the next mountain range, I call these the zigzag. They go.
Yeah.
Top-blade. And then the Ripheus Mountains. I'm not saying that. It's that Greek letter, the one that goes mu. So right down below Apollo 12. Down? There, you're on it.
Am I? Is it this?
That, yeah. Okay. So that's that like Greek letter.
Oh yeah, it looks like mu, like a backwards mu.
Yeah.
Or if you go upside down, like lambda.
I guess so, yeah.
Oh yeah, it could be lambda, yeah.
So to me, it's like it's the coefficient of friction mountains,
That Sounds reasonable. See,
Yeah.
that's the kind of thing you'd write in your notes. All right, cool. So that Mare Cognitum is not one of the ones on the list, but cool to see it anyway.
It's cool because that means the sea that has become known, I think.
Oh, that's
Ooh.
neat.
Yeah.
How very poetic.
I was saying to Jenna, the one thing mountains remind me of the moon is like Lord of the Rings maps. I don't know why. If you open a Lord of the Rings book, they kind of look like the ones they describe to cross them.
Totally.
And then we have beside the Ripheus Mountains. So over here in Mare Cognitum is the Ranger 7 landing.
Yeah, so those are pre-Apollo missions. And I think Ranger 7 I don't think it landed. I think it crashed. So they just had video cameras on and they just flew them into the moon, taking pictures all the way down, which is much less expensive than actually building a lander, because with the Ranger missions, for the most part, they just stuck them on top of missiles and
just go boom. There are some actually really cool examples of doing that and measuring how it affects the what's like the gravitational sensors and like earthquakes and stuff, or moonquakes.
Yeah, there's a couple of ways because there's lots of seismometers on the moon.
Mm-hmm.
And there was a mission in like 2009 or something. It was called L-Cross, and they flew an impactor in, and and then they could measure sort of moonquakes all over the moon and stuff like that. There was another one earlier, like during the Apollo era, because the third stage or something of the Apollo rockets would impact the SRB, and so that would shake the moon, detectable enough from the seismographs. So
cool.
Yeah.
Next crater down is this one here, which is Borealis, and it's the biggest crater in the lowest mare, or the most southerly mare. So that's a relatively easy one to find as well. Yep. And then I just do terribly down here because there's so much going on.
So the way that you do these craters down in the sort of the crater soup is first you find Clavius, which is the one with the sort of the fractal pattern. Yeah.
That one was viewable. I think it was on the list yesterday because I found that.
Yeah. So Clavius, I'm probably not even saying that right, is your base of operation. So you sort of go out from there. So on my notes, anywhere where I'm at the bottom, if I recall, I would draw Clavius and then put the neighbors in. And do everything relative to that. Because like even right above, you've got Tycho there and you can't see its rays yet. Mm-hmm. But you can sort of find it relative to that, which I call Clavius the Swiss cheese crater, or Clavius.
It has that very distinctive pattern of really nice, pretty little craters in it, which helps a lot.
Yeah.
When I saw it last night, it reminded me of Mickey Mouse because I was using a really small Cometron first scope, so I could only see the two craters at the sides.
These two?
Ears. Yeah.
Mm-hmm.
That's pretty cool.
We have a question about the straight wall. Someone trying to locate it?
Up to the straight wall, yes.
Yeah, so it would disappear. Oh, yeah. Straight wall versus straight range.
Oh, what's
Do you know which one they're talking about?
Oh, James, can you clarify? Are you looking for the straight wall or the straight range?
I don't have the chat open.
Where is the straight wall?
I think
this is the straight range.
Yeah, so the straight wall is not a target on Explore the Moon, but it's in it's almost along the center line of the moon, and it appears at about, I want to say Lunar Day 8, so like Q Day 1 or 2. Yeah, in Mare Nubium, I think. And it's beside the crater Burt. And the issue here, there it is, you got it, is that you see it because of the shadow, right? Mm. So, a couple of days later, it's just sort of gone, and you can catch it on the other side too, like on the other Q day where it laps, and then it's illuminated as when the sun shines on the cliff, because it's that kind of fault where like a slip fault, or there's another word for it. So except it's more of a gradual slope. It doesn't actually have that much of an incline either, so it does take quite a bit of you got to have the angle to get that shadow,
right?
Yeah.
So for now, this is just a little range of mountains that looks straight and or like a hot dog.
Like a hot dog.
Yeah, this one's a lot harder to see.
The straight wall.
The wall is easy to see on the day that it's visible.
Okay. Yes, and it's not a target for Explore the Moon.
It's not a target for the.
Okay.
It's Dave Chapman just said the straight wall is an ETM telescope one. It's labeled.
Oh, it
F.
is.
Oh,
Yeah.
okay. All right. We'll get to that on a different
The
day.
expert
then.
himself.
Good correction.
We'll get to that on Q day 1 probably because it's a little past its best right now. So for now, they are quite far apart from each other, though they are both near the middle. And the straight wall is a wall and the straight range is mountains. And that's a relatively clear, because the straight wall is basically just a line. All right, let's go into craters because we've been looking at lots of craters and there's some really cool ones that we can look at this time. We're going to do a demo on this, but first I just wanted to go over some of the different parts of craters because there are different types of craters when you're looking at this stuff. Copernicus being a good example of a complex crater, which means that there's more going on than just a circle. So in this case, it has these ridgy walls and it has this central peak, which is like a little tiny mountain in the middle of the crater. And a couple of other ones have that too. You can see Landsberg has a nice central peak as well. Some of them, like I don't know what this one is, but this is a very basic, just plain little punk.
Yeah, I think we call those the basic ones like bowl craters or something. Like
yeah,
bowls.
I've heard them called simple craters too. And like, they're just kind of, meh, they're just there.
A lot of my
I think they're
readings
cute.
just called them simple craters. I think I called them boring in a lot of my descriptions, unfortunately.
Rude. You get other features too, like this one over here, for example, is filled in with lava. So that's one where lava has come up from the bottom and yeah, kind of obscured what was going on in the middle.
Now, do we know, would those be older or craters because they're filled with lava or?
Well, they're older than the mare.
Yes.
Okay.
Yeah. And then you have ghost craters too. So that's,
Oh yeah,
they're
we got
the
a
ones
photo
where
of
you
that.
almost entirely fill them up.
Like this one was a ghost crater sort of, eh?
Yeah.
The one in the background, this part here.
'Cause
So
it-
yeah.
Yep.
So there's some cool stuff that you can learn from craters. One of the nice things is about them is that they show you a history of the moon. So people have whole degrees in this about aging the moon and using how many craters are there as and what's happened to them over time as an idea of how old certain parts are. And in fact, this was a really cool one that John looked at. This one is called the Lichtenberg Crater, which is not a target. It's 20 kilometers across on the far west side of the moon, like right on the edge. And two cool things to note about this. There's an old crater beneath it. So this crater, sorry for my hover zoom, this crater is newer than this crater. And the other cool thing is that lava has come in and covered up part of the ray structure. So these rays here, these like lighter bits that come out, that's stuff that's come out from when something has hit the moon and launched bits of debris outwards. And lava has come in and covered up this side, which you can also tell because there are fewer craters, little tiny baby craters here than there are over here. So this is newer rock.
I think one thing I conceptually miss until I was starting reading more about craters is how big they are. Because they look like little tiny spots on the moon, but I'm just imagining running 12 kilometers or trying to walk 12 kilometers across it. It would be massive.
Especially because every pixel is about a kilometer.
Yeah.
On the picture, right? So it's pretty far out.
And bringing it back to the Earth here as well, there are, and Samantha, maybe you can jump in on this, there are a bunch of cool craters on Earth.
Yeah. So this one's in Quebec, which Jenna just shows up. And the thing about Earth is we have a little bit more protection and kind of recycling than the moon does. So we don't have as many craters, even though we do have some, like this really cool one. Basically, well, we have the atmosphere, and that also creates erosion. That's why the mountains in the Appalachians out down east are a lot less prominent than the ones out west because they have been eroded. But the big thing is our tectonic activity actually is like recycling the Earth's crust. So unlike the moon, where these craters could be like millions of years old, correct me if I'm totally wrong with that.
Yeah. Billions.
But billions. Okay, I didn't want to say billions because billions of years old. By the time if we had an impact around the same time, then the crust would move. That's as you know, we have the Mid-Atlantic Ridge that blows up new crust, and the what is the Marianas Trench? I'm trying to think. In the Pacific that eats up the crust. So it was gone. We've recycled our land. And I think John had another cool fact about the Earth, the time that the moon, a lot of the craters are from, and what happened during the Earth around that time.
I don't remember which.
It was the
I don't remember
Copernican
that.
era. Is it the Copernican era?
Yeah, so I think the Copernican era. Now I'm guessing they have an approximate age for the Copernicus crater, and then so they're just labeling or naming craters that are newer than Copernicus, which is about 1 billion years ago, as sort of like Copernican era craters, and then before that. So that's sort of like a divide
That's cool.
to divide up the eras.
But you're saying, I guess most of the Earth's crust have been recycled within the time that.
Oh yeah.
Yeah.
So within that period of time, most of the Earth's crust, has been recycled, with the exception of the Quebec and the Canadian Shield.
Yeah, so Quebec has a lot of craters in it because
Sudbury Basin.
This is Canadian Shield. So first of all, there's that crater is in northern Quebec. Then this crater here, which has seen some weathering from glaciers, is in Labrador, but it's pretty close to Quebec. And then we have these two little craters here, which turns out are actually two separate impacts. They were theorized for a while to be the same chunk of space debris that separated as it came through the atmosphere, but in fact, it looks like they're from 4 million years apart. Also in Quebec, and this is also, surprise, surprise, in Quebec. There's a lot of old rock in Quebec, so that helps a lot, and it's very hard rock. That's that granite that you see in Northern Ontario and in Quebec. Also, Quebec's big, so that has something to do with it too.
Somebody mentioned the Sudbury Basin being a crater. So people in Sudbury.
Yeah, it is. It's not as obvious because there is no water necessarily like filling it to make it look circular. But it is a crater, and that is why they have so much mining in Sudbury, is because asteroids came in and deposited a whole bunch of cool metals.
Yeah, I'm not sure if it's that they deposited it. It's like what it does. It creates a lot of heat when it goes in. So it does something to the chemical composition of the rocks that, separates the metal from the rock in such a way, or like some such thing. So it's not necessarily that we're mining nickel from space. We're mining nickel that's,
been created by this process of snatchy.
Yeah, been created by the processes. Yeah.
There's Nickel Center, for example. So
this makes a lot of sense why a lot of earth science classes, when I went to Waterloo, like to drive up north, like we had a trip to Bancroft. I'm not sure if it's that for north, but got a lot of old rock fans in the earth science department at Waterloo.
That's true.
Yeah.
Hard rock. There's a divide between sedimentary people and hard rock people. So
so I just realized that I'm poorly prepared for this. And we're going to do a demo for setting up craters, except I forgot to set up my phone beforehand to give you a better perspective. So we're going to just unplug my laptop and hold it up. So here's a tour of my office/gym. This is one of my favorite demonstrations to do with anybody, really. We did this at the 2019 GA, dropping impact, like meteorites and such, from the 3rd floor of the York University Student Center. It was great, into a kiddie pool full of flour. This is smaller. There we go. So this is our little lunar surface. As you can see, maybe see, we have cocoa powder on the top and flour in the bottom. And that sort of simulates the two different layers of rock on the moon. If you want to make it more scientific, you can add more colors of things or sand or something like that. And then we have, I have popcorn, peanuts, chocolate chips. It's what I've been munching on throughout this program, and marbles. So we're going to try doing some impacts. Alrighty. I'm going to have you guys give me some feedback on this because I can't see this at the same time as throwing stuff. Can you see it there?
Yeah.
And can we change your view to make you full screen? Or I guess if you switch to speaker view, if everyone in that's
there we go.
watching,
all right.
Yeah, go to speaker view.
We should be good now.
There we go.
Alrighty. So we have, I'm going to start with the popcorn because it's the smallest. And the popcorn, there's a lot of different factors for what craters will turn into when you impact it with things: speed, size, material, that sort of stuff. I'm going to throw this as hard as I can without losing it somewhere else in my apartment. Are you ready? 3, 2, 1. Ooh.
Ooh.
That's nice. So can you see that close up? We've got some rays. And we've got terraced walls, actually. I don't know if you can see that much detail. There's some cocoa powder on the inside. A nice little circular crater. Shall we try for the chocolate chip? Can you still see it?
Yeah.
Sweet. Okay, ready? And this time I'm going to throw it from an angle, see if that makes a difference. Ready? 1, 2, 3. Well, I almost missed. So that's not great. All right, I'm going to try it again and move the laptop back a tiny bit. There we go. Can you see?
Usually go up just a bit.
Up just a bit.
Up, up, up. Okay.
Is that good? I'm gonna peek
Sort
my
of.
head up. Okay, sweet. Yeah, ready? 1, 2, 3. Hey! Also, this is messy, just a heads up. So in this case, all the ray ejecta went that way because I threw it from this angle. And so you don't see rays over here, you only see rays on that side. And again,
Fortunately, chocolate chip didn't dissolve like most
yeah,
asteroids.
that's
Yeah,
you go ahead, Samantha.
I said, I read online, apparently, if you, in the future, if anybody wants to try this, you mix like water and flour together and make it a ball and then throw it pretty hard, it will actually like dissolve, but.
That's cool. And I guess, yeah, so one of the things to note as well is that when you're doing, well, when you're doing this in space, when space is doing this on its own, it's the impact that causes the crater, less so the object itself. So as the object hits the moon, it's going really fast and it explodes on impact, which does a lot of the throwing of material, which is also why oddly shaped objects like chocolate chips and peanuts and whatnot still make circular craters. All right, I'm gonna throw the peanut super hard straight down. Are you ready?
Yep.
Oh my goodness, I'm terrible at this. Okay, I'm gonna do it again. Ready? 1, 2, 3. There we go.
Oh, giant one.
That's a good one.
Nice.
And there you can really see how the surface material has been pushed down into the layers below. And you can see the rim of the crater has this like little rim of material built up around the edge. All right, I'm gonna do one last one and try to get it on the empty side of the container over here. And it's gonna be this. So, oh, there's already cocoa powder all over my laptop. I just realized that from this view. Okay, we're gonna try one more time. You ready?
Go.
This time I'm just gonna let it drop because otherwise I'm gonna miss. 1, 2, 3. Woohoo! I'm gonna carefully lift that out. That's a nice crater, nice big one there, right?
Yeah, I mean, a couple of takeaways is that, you know, the crater that it makes is much bigger than the object.
Yeah, true.
And that's amplified, you know, many times over with the lunar craters. So those, you know, those craters could be hundreds of times the diameter of the rock that made the impact. And it also doesn't really, for the lunar craters, they're coming in so fast that it almost doesn't matter the angle. Unless they're below like 5 degrees, they're going to make a round hole. Because it's really just all that kinetic energy from the object moving at high speeds being turned into heat when it hits the moon. You know, makes that huge explosion and makes this giant bowl-shaped hole in the ground. So
somebody asked, is all like, so the impactor is almost always disintegrated? Is there ever a case that we're going to see the impactor after the crater?
Yeah, I don't know. I mean, so I feel like the only way you would know that is to sort of like X-ray the ground or do a lot of, you know, really study it. So again, I don't know. Maybe that'd be an interesting question to pose to someone in the mine there in Sudbury. Like, have there been pieces of the original asteroid found? My gut says that I heard no, but I don't know.
I think there are. Well, I mean, we certainly find on Earth, bits of asteroids that have hit Earth.
Yeah. So you find pieces of meteorites and stuff, but of the big ones, right? Like the one in Arizona and all that, you know.
Yeah. I'm
not sure even if you go digging that you actually find any like solid chunks.
Yeah, it might just like melt or combine with whatever it's hit. I don't actually know for sure.
Another question, sorry, is that brown stuff, the cocoa powder going in, is that what kind of makes the complex craters, the little like mountains in the center?
I believe so, but I think it's also like something to do with the physics of it, like that the impact creates the ridges on the side, and it makes it particularly visible with the cocoa powder. It
has something to do with like the waves of energy, so they bounce and, you know, waves go out, interfere with each other, and come back.
And that's also where the central peak comes from, is that like rebounding, it'll come back up, but we don't see that here because this is a baking tray with flour in it. And it isn't a perfect model. That's the key, is that it's not exactly what happens. Also a really, really good idea from Jamie, which is try to do this with a recipe that can be turned into cookies later, because you start to smell the cocoa powder and it's like, that's all I want now, especially with kids around. And basically I am a child. So I very much want the cookies afterwards. Yeah.
Even cake mix, like vanilla cake mix, and then put some cocoa powder on top, just buy a box. And then after, just throw the eggs and oil in and bake it in the pan.
Don't use popcorn kernels as crater, as bits of space matter, as asteroids, because you cannot eat those afterwards, or you can, but it's very uncomfortable. Definitely
What
don't
would happen if
try it.
you then bake your cookies and the popcorn kernels in there and they just explode all over inside your oven?
I don't think that's how it works, but
but it's an experiment that should happen at some point.
Yeah.
Awesome. Okay, so this is actually, we have gone over time, but this has been fun. I'm gonna go clean up my floor. I recommend that you all try this though. It's really fun. It's a really nice activity, especially if you have kids around, but in general, it's a really nice way to visualize what you're looking at. And you can try to recreate some of the craters that you find. See if you can recreate Copernicus.
Okay.
And if you go out viewing and manage to snap a picture through your phone, I really tried hard last night to do it. #RaskMoonAtNoon on social media. I'm pretty sure we can Facebook, Instagram, Twitter. I mean, I'm an Instagram fan. Maybe that's my generation, but
technically we are also on TikTok, but I don't know. You could maybe take videos of the moon if you wanted to. So give it a try and see if you can. I'll certainly be trying to go out tonight if the weather clears up. And so hopefully you all make it out as well. And we will see you next week for our troubleshooting episode. We're going to go over all the problems that you've had so far. If anyone has problems with viewing, all that sort of stuff. So if you haven't gotten out yet, get out before next week, because that's when we're going to talk about any issues that you may come across.
Can't wait.
yay.
Can we?
I said, I can't wait. I have all
I
sorts
can't
of-
wait. Yeah. Yeah, it should be good. I can't wait. It'll be good. All right. We'll see you all next week.
Bye.